Have skies. Well, it was sitting there.
Oh, is it discrete random
You've got one.
variables?
No, it's in that topic, yeah. Okay, so can I get you guys to get a title down? Discrete. Probability. Probability. Okay. The word discrete, what does it mean?
Non-obvious.
In like modern day slash Englishy type of situation, if you said someone is very discreet, it means that they don't go blabbing. They keep what they know to themselves. They can be trusted with a secret. That is what someone who's discreet is. In math, it has a bit of a different meaning. Well, it would be weird if we were talking about numbers that don't go blabbing. So in math, there's basically numbers can be split into two different categories, discrete and continuous. Would someone like to hazard a guess based on that what a discrete value is? It ends. So something like pi is not a discrete number because it goes on forever. Jamming out there, Alyssa. A discrete number is one where, it can only take on certain values. So in probability, that would be an example of a discrete statement. In probability, a discrete probability is one where only certain events can happen. So a discrete probability might be something like I flip a coin, there's only two options, heads and tails. I did. So discrete is where there's certain possibilities. Continuous probabilities are where there's more than, like there's many possibilities. Okay, so a discrete probability distribution is basically a table that says all the possible outcomes. So, would look like this. That's what a discrete probability distribution looks like. The top row are my outcomes. The bottom row are my likelihoods. So what does that 2 represent? An outcome or a likelihood? Outcome. So there's 3 options here. Either I have nothing, I have 0 of the thing happens, I have 1 of the things happen, or I have a 2 of the things happen. Could anyone look at that and think what that situation might be showing? I have 25% chance of 0 things, 50% chance of 1 thing, and a 25% chance of 2 things.
Flipping a four-sided dice with 3 things on it.
Well, you're kind of on the right track. It's if that would actually fit this. If that you had a 4-sided dice with a 0 on one side, 1 on 2 sides, and 2 on one side. But in my head when I was making this is flipping 2 coins, and X is the number of heads you get. So I'll just make that note. These are my outcomes, e.g. X equals 0, X equals 1, X equals 2, where X is the outcome of the event. Then down here, we have the likelihoods. And so, e.g., I drew that P very well. Probability of x equaling 2 equals 25%. Does that make sense, guys? You can just look at the table, see what the outcome is, what the likelihood is. Are we feeling all right about this so far? What we're going to do is we can use these probability distributions to find a couple of different things. We can find the expected value of this trial or experiment, whatever you want to call it. We can find the variance and we can find the standard deviation. We're going to try and find all of these things. So we might do one that'll lead into the expected values. Let's go to the Bowen show. And I'm gonna set up a stall at the show. And my rules are I roll a dice. How much should I charge people to play my game? Ooh, big spender. $10 to play. If you roll an odd number, you get your money back. No, I'm gonna give you that's too much. If you roll odd, I win. If you roll a 4, you win $5. Me, I win.
So you lose
The player would lose $10 on an odd.
So just say loss. I win.
Player loss. A 4, you win $5, and on a 6, you win $10. Nope.
4.
Oh yeah, you'd get handed $15. That's right. Yeah. Okay.
What do you mean 4 equals $25?
Well, you're rolling a dice. So if a 4 comes up, you get that. How many outcomes of this game are there when I'm rolling this dice? Nope.
How many outcomes is?
They can lose, they can win $5, or they can win $10. So there's really only 3 outcomes, which is a bit better. So I'm going to construct my probability table, guys. I didn't think about it. 2. Let's say a 2, they get money back. So now there's 4 options. So, what's my first outcome? Lose. So we're going to be doing math to these, so we need to represent the loss as a number. What number would we use for a loss? 0. We can do that, but it's going to make the math later harder. Is there anything you're not accounting for in that 0? If you rolled an odd, do you walk away and nothing has changed? You've actually already paid $10 to be here, so the outcome of you losing is actually minusing $10 away from you. Okay. What would be the next outcome? So you can have an outcome of 5, you can have an outcome of 10, and what else? 0. What's the likelihood of me losing $10 or the player losing $10? Yeah, 50%, 3 out of 6. What about a 5? What's the probability that someone wins $5? 1 out of 6. And these other two are going to be 1 out of 6 as well. Okay. Big note, guys. For a discrete probability distribution, the sum of your probabilities has to add up to a certain number. Does anyone want to guess what that number would be? 1. Really common exam question. I give you a probability distribution with one of the probabilities missing. And you've got to solve it. So you've got to work backwards to figure out what the missing probability is, so on and so forth. So always remember the bottom row has to add up to 1. Okay. Expected value, guys. Remember we talked about the Greek letter mu is the expected value. Expected value is mu. So mu is sometimes written as the expected value of x. And the way we calculate that is the sum of our outcome times the probability of x. So that might look a little bit, I was about to say like Greek, and it literally has a Greek letter in it. Look a little bit confusing. The way I find the expected value of something is I just take the probability of each event, multiply it by its outcome, and then just add all of those together. So take the probability times the outcome, add it together. Make sense? Question. If my carnival game up above is fair, so equal chance of winning or losing, what would the expected value be? Sorry? Nope.
1.
Nope.
0.
0. Because the expected value is how much you win. So if it's fair, you would win as much as you lose, and it would cancel out at 0. If my expected value for that game was positive, does that mean me running the game is winning more money or losing more money? It means the player is winning more than they lose. So is it like, this one is not a fair game. I've made it so it's not fair.
At that time of year, you're not going to lose and win.
So what I've done there, and you can probably see,
if you had a negative
half the time they're losing $10, and then if you add up the other 3, on average they're winning about $7.5. So I would expect to, on average, win a couple of dollars each time this game is played. Now, obviously, any individual game, someone might roll a 6 and win their $10. But on the long haul, I would expect to be winning more than I lose running that game. Okay.
It's not really a carnival game there, so it's more of a
Attention staff, I'm looking for Mr. Watson's HCE class. If anybody has seen Mr. Watson's HCE class, please contact them. Thank you.
So, I was talking about this the other day, like the house knows what their odds of winning are. So, like, a casino knows that on an average hand of blackjack, they expect to win 10% of whatever was bet. Like, they have an edge in the maths of how the blackjack game works. And they do this maths to figure it out. So let's find the expected value of the above carnival game. So we have mu equals the sum of x times the probability of x. I'm just gonna make a quick note here. You sometimes see this written as the probability of x equaling x. I like to use probability of x just for simplicity, but you'll see that in your textbook quite a lot. They mean the same thing.
What was that?
See, the probability of big X equaling little x. So that what that means is the probability that the thing you get is equal to the thing you want. I just like saying probability of x because it's simpler. But you will see both. So all we've got to do is for each outcome times it by its probability. So our first outcome is the player loses $10. Sorry, little x. So capital X equals little x. It's fun to do. Okay. So negative 10 times, and its likelihood of happening is a half. Plus, our next outcome is 5 times 1 over 6. Plus, and then we have 10 over 1 over 6. And then we have 0 times 1 over 6. And doing the math on that, we end up... I'm going to leave this as a fraction because I'm going to simplify it. If you do it in your calculator, that's fine as well. Just for sake of argument, I'm going to do this as a fractions. So negative 10 over 2 plus 5 over 6 plus 10 over 6 plus 0. I'll turn that negative 10 over 2 into an over 6. Negative 30 over 6 plus 5 over 6 plus 10 over 6. Which if I add them up, negative 30 plus 5 is negative 25. Plus 10 is negative 15. Yep, negative 15 over 6, which is 2 and 3, 6, which is 2.5, which is $2.50. Sorry, negative. Therefore, players should expect to lose $2.50 per game. To go back a couple of minutes, guys, first we were going to make it so that rolling an even, it just came out as 0. We could have done it that way, but after we figured out the expected value, we would have had to minus away $10 because that's what it costs to play. You can do it that way. I prefer to do all of the, figuring out cost at the beginning, just make it a little bit simpler. Questions, comments, concerns? Pretty basic, pretty self-explanatory. You guys all right with the sum of x times probability of x? Yeah. Okay, let's do an example. No, you don't. Does anyone work at IGA or Woolworths? This is a checkout adjacent question. E.g., let's say a store has does not have an E in. A store has 3 checkout lanes. The probability of how many lanes are in use at once are shown below. use this info to decide how many cashiers should be on staff at any time. Okay, so I might make it so that we have 3 checkout lanes. X, probability of X. So we have no one is using a checkout, 1 person is, 2 person is. Maybe I'll just do 3. We'll do 3. Okay. So I am done. I've obviously deliberately left that one empty. Can't take you anywhere, Arlen. What the hell? What even happened? Yeah, you just fill it in. You figure out what it is, fill it in. For the second part, use the info to decide how many cashiers should be on stock. How could we do that? How could we make a recommendation? Oh, you should have 2 cashiers or 3 cashiers or just have 1 cashier.
Just how like
So could we just look at the table and straight away know? Probably not. But if we found the expected value, if we found the expected number of checkouts in use at any time is like 1.3, how many cashiers should there be? Probably 1 or 2. Depends if you're trying to save money or if you're trying to like make it as efficient as possible, I guess. But would you, if it was 1.3, would you be putting on 3 cashiers? No. But so that's what we're going to do. So I'm going to solve this one in blue. So step 1, how am I going to find the missing number? Yep, so I know that is not a sigma. The sum of the probabilities of x equals 1. So therefore 1 equals, I'm going to call that one, I don't know, A. A plus 0.2 plus 0.5 plus 0.1 equals 1. 1 equals A plus 0.2 plus 0.5 is 0.7, 0.8. Therefore, A equals 0.2. I think for something as easy as that, I would not mark you down for just filling it in. You will see ones on the exam where there's like 5 or 6, or like there'll be fractions, so I would probably need you to do the working out on those ones. More for your own benefit than for me marking it wise. Okay, so we know that A is 0.2 because a discrete probability distribution has to show you every possibility. So all of those probabilities have to add up to 1. So 0.2 plus 0.5 plus whatever that is plus 0.1 has to equal to 1. If you add up those other 3, you get 0.8. So we know that that number plus 8, yeah, just minus 0.8 from both sides. Okay, so now we want to make our recommendation. We know that that is 0.2. Gut feeling, guys, are we going to be suggesting how many cashiers?
1.
1? It is the biggest. Does anyone think we'll be suggesting more than 1? I would say very likely. We'll be probably end up suggesting 2. I reckon the number will be around 2-ish, either a bit above or a bit below, would be my guess. But that's without doing any calculations in my head. The reason, by the way, guys, I always try and do my gut feeling check before I start is A, if your guess is way off, it lets you know that you're not considering something when you're going to solve this. And B, if you're pretty sure you've done the maths all right, but it's way off from your guess, there's a good chance you haven't done the math right. And you may need to go back and check that. Okay? So let's solve it. So let's find the expected value, mu. I'm going to keep writing mu and then ex. You will see both, as always, equals the sum of x times the probability of x. You know what, I might use the other one this time. Probability of big X equals little x. So, first one, 0 times 0.2 plus multiply. It's just shorthand for multiply. I don't use it very often, but the textbook does use it. 1 times 0.5 plus 2 times 0.2 plus 3 times 0.1. So that gives me 0 plus 0.5 plus 0.4 plus 0.3. Oh, my answer is going to be a bit off. Equals 0.5 plus 0.4 is 0.9 plus 0.3 is 1.2. Whoa, that was supposed to be a 2, and yet I drew a 3. 1.2. So on average, there's only 1.2 checkouts being used. So depending on whether you want to save money or be efficient, you'd probably suggest to that store owner 1 or 2 checkout people. If you don't care about having a lineup, just do 1. If you do care about having a lineup, have 2. So the store should have either 1 or 2 lanes staffed, depending on store priorities. So if the store is worried about turning a profit, they might want to drop back to 1 staff member. If they really want to have like people in and out the door, they might put 2 on. Okay. Questions, comments, concerns? Pretty basic. Okay. I might steal. No, I don't like that one. I'll use this one. Okay. There's 2 more topics. We have standard deviation and variance. Have you guys ever heard of variance before?
Yeah.
Some of us a little bit. Variance sucks. I don't know how else to say it. I'm sure it has a use somewhere. There's not much of a use for it in high school, aside from you use it to calculate standard deviation. So you guys aren't going to be asked to analyze the variance. You're not going to be asked to do anything with the variance apart from calculate it. The reason I bring that up is because you might look at me and say, what is variance? And the answer is it doesn't really matter. The full answer is, where is it? The variance is a measure of the spread about its mean. Can be considered the long run average of the value of the square of the distance from x to mu. We use the letter sigma square. So variance. So variance, we use sigma squared. And it is equal to the sum of x minus mu squared. So to solve this one, guys, first you need to have that mu value. You need to have that expected value. You take each and every x value and you minus away the expected value from it. Then you square that number, you add them all together, and that is your variance. Very annoying. So that is one option. The other option for this formula is you can do the expected value of x squared. The expected value of x squared minus the expected value of regular x squared. Both of those formulas do the same thing, just sometimes it might be more convenient to use one or the other. So in the first one, we do our mu formula, but we square each of those values. In the second one, we take the expected value that we already calculated and square that. So it's a bit of a pain. Both ways are a bit of a pain. I won't ask you to do this tech-free with more than like 2 or 3 values because it's too much work otherwise. So let us have a look at finding variance. So we have a distribution table like so. And I'm going to split this one into 2. So find, the way we write it is variance of x, or we write sigma squared. You'll see both, as always. I'm going to do it option 1 way and option 2 way. So option 1, of course, is sigma squared equals the sum of x minus mu squared. And option 2 is, of course, sigma squared equals the expected value of x squared minus the expected value of x squared. Very annoying. It's also very annoying. Oh, sorry, I've forgotten a part of this. Let me just... Very good. Oops. Okay, do we want to do option 1 or 2 first? Option 1, yes. To be able to do option 1, what have I got to find? No. Sigma is a Greek letter. In this, sigma by itself is the standard deviation. Sigma squared is the variance. So the standard deviation is just the square root of whatever our variance is. How could... To use that rule, do I know what my x values are? Do I know what my probabilities are? Yeah, well, they're written in the table. I don't know mu, so I need to find mu to be able to use this rule. So let's do that quickly. So find...
This is on the exam.
Find mu. Mu equals the sum of x times the probability of x. Sorry, I should probably keep my notation consistent for this question. And I'm using x equals x. Once again, means the same thing. You will see both. So that'll be 0 times 0.08 plus 1 times 0.18 plus 2 times 0.4 plus 3 times 0.34. And if you add them all together, you get 2. Okay. Now we can do our sigma squared. So sigma squared equals... I'm just going to jump straight into my rule. It's going to be x minus mu and then square it. So my first x value is 0. So 0 minus 2 squared and then times by the probability. 0.08. So it's going to be the exact same as the line above, but instead of 0, 1, 2, and 3, we're going to be using 0 minus 2 squared, 1 minus 2 squared, 2 minus 2 squared, and 3 minus 2 squared. It's a real pain in the butt, which is, like I say, this is why we don't get you to do more than a couple. It's too much work. Which gives us, I think, 0.84 if you put that all into your calculator. Once again, do I expect you to interpret that 0.84 number? No. The only thing we do with that is use it to find standard deviation. That is your variance. Sigma squared is your variance. The variance of that data set is 0.84. So if you do want to know what it means the average distance of the square between the data point and the mean. Do with that what you will. Questions, comments, concerns on option 1? No. Okay. So, option 2 is a similar setup. In the sense that we're finding the expected value, but this time it's of x squared instead of x. So what we're going to do is take all of our x values and square them and do the expected value like that. So that'll be 0 squared times 0.08 plus 1 squared times... I've completely lost my train of thought. 0.18 plus 2 squared times 0.04, or 0.4 rather, plus 3 squared times 0.4. But then I need to minus away my expected value squared. Now, normally you'd have to do that exactly what you've got written above, but minus the squareds. And redo that. We've obviously already calculated the expected value as 2. So I'm just going to highlight that my expected value we've calculated over there. I'm not going to make you redo that. So I'm using blue, minus 2, and then squared. If you put that all into your calculator, you should get 4.84 for that whole first bit, ex squared, minus 4 equals 0.84. Negative 2 squared. Sorry, minus 2 squared. So 2 squared is 4, minus 4.
Where's the 4.8?
So the 4.8, I'll just highlight so it might make it a little bit clearer for you. That becomes the 4.84. The negative 2 squared becomes the minus 4. So the 4.84 is the expected value of x squared. The 4 is the expected value of x squared. We got to the same answer both ways. Okay. Questions, comments, concerns, guys? This one, I think, is the worst part of this. It's annoying. The formula sucks, and I hate it. It's finicky, and there's lots of ways to make mistakes.
Hey, sir, it's negative 2 squared. Wouldn't it be 4?
It's minus 2 squared. So the 2 is the negative is not being squared. You're right. If the 2 was inside, the negative was inside the brackets, it'd be positive.
So you said the blue, so like expected value of x squared, expected value of x is just mu.
Yeah. And because we already calculated mu, I didn't want to go through that again. Obviously, if you hadn't have done option 1 first, you would have had to calculate mu there. Okay. If we look at standard deviation, guys, I'm not going to do a whole separate question for this. So standard deviation, the standard deviation of x, we use the Greek letter sigma, not squared this time. So just sigma by itself, and that is the square root of the variance of x. So in the above question, to find the standard deviation of that data set, what would I have to do to that 0.84? Just square root it. That's it. So e.g.
You write that same as sigma equals square root sigma squared.
Yes. Find SD of above question. Sigma equals the square root of the variance, which is the square root of sigma squared, which is the square root of 0.84, which is some number. I'm not sure what it is. Process. .91 ish. 92 with rounding. Okay, guys, facts time. These are the facts I want you to take away from today. Discrete means only certain things can occur. If there's more than a couple of options, it's not discrete.
What do you mean? More than a couple of options.
So, if my experiment is whether Sky or Sajith comes through that door, but everyone is in this class, and I only put down Sky and Sajith as my options, either it's
a rule that we did the other day. It's like you've only got win and fail.
Yeah, it's a very similar idea, but obviously there's now more than 2 options. But there is still limited options. It's kind of like saying I tested everyone for whether their height was 152 centimeters or 168 centimeters. Obviously, there's a lot more than those 2 options. So I'd either need to give every single option probability, or I'd have to not treat it as discrete.
What page was that on?
The textbook, 746 is what we're about to look at. That has the summary of it. So discrete. Next, probabilities have to add up to 1 in your distribution. That's an important thing to remember. And then you have your rule for expected value, variance, standard deviation. There's 5 things I want you to remember from today. Discrete, add to 1, expected value, variance, standard deviation.
So that's where you got the writing from page. So of course it was the tables on that.
Oh, the table is the previous page. Guys, I want you to have a go at question 1 and 2 on page 746. Now, question 1 and 2 are just about expected values. But can I get you for question 2 also find your variance and your standard deviation for those ones? More than welcome to use calculators for these ones, guys. I'm not going to make you do these tech-free because they do take a while if you do them tech-free. But can I get you to have a go at those questions for our remaining time?